Hi everybody, welcome to this lesson in our Arduino microcontroller. Today we're going to be covering basic circuitry, and we have to do this because we have to understand the diagrams and basically the circuits that we create in Arduino. And if we don't have a kind of a conceptual or basic understanding of that, then we might find ourselves getting into problems and even potentially overloading our board and destroying it. So we want to avoid that at all costs. So what is a circuit? Well, honestly, it's just a closed loop that electrons can travel in. So I like to imagine it as like a racetrack or a NASCAR racetrack, right? You have all of these race cars there, okay? And they're all stuck together, and we can consider those like our electrons. And then they have just a loop that they're going to be going around in. Now, what happens is if you were to swap one of those cars, right, and force it to go a different direction, well, everything's going to break. And that's kind of the same way when we design our circuits. If we're not following the standard flow of positive to negative, right, and instead maybe we swap that where it went negative to positive, everything could break. So this battery were to be flipped here and then it's going here, it could essentially overload whatever different thing that we're using in our Arduino. Now, there are two types of circuits that we need to know. There is the series circuit and the parallel circuit. The series circuit, basically everything is going together in a specific order, and that flow can happen. Think of Christmas lights, right? Christmas lights has a string of all these lights, and one light dies, and then you get like the whole strand dead until you can find where that burned out light is. That's a series circuit. A parallel circuit, however, is more of like a ladder, right? So you have everything, the electricity flowing how it should from positive to negative, but then you have these rungs of a ladder where you have your different devices, whether it's a microphone or a light bulb or anything like that. And what's cool is then we can put switches in different portions of that ladder leading up. So maybe I need to have a light bulb permanently on at the bottom rung of my ladder, but then I want to go up to the next step. I can actually add a light switch or a little switch after the light and then control everything beyond that with it. And that's why it's useful, especially in Arduino as we start branching out and using more and more stuff with it. So this is what the series circuit looks like, right? Just like the Christmas light analogy, everything is going in one specific direction here. And say this light bulb dies right here, this light bulb won't work, and then that goes here, and then this light bulb can't work because it can't complete the connection all the way over here, and everything's broken. And then there's the parallel. As you can see in our parallel circuit, we have these kind of rungs of the ladder, and the flow of electricity is going around just like it would. But you can see it also branches off here. So let's say, for instance, this light bulb here dies. Well, this light bulb here and this light bulb here are going to be fine because the electricity is still flowing to them and then completing the circuit that way. If we wanted to, maybe we only want to control this light bulb, right? We want that to be on a switch. We could put a switch right in this portion here, and then it would just control this light bulb and flow back. Maybe I want to put a switch here and control only this light bulb. I could put it right here, and it wouldn't affect the flow of these two lights from operating. It would only affect this one. And that's why a parallel circuit is important. Now the question you might be asking is, so why use one over the other? The parallel circuit seems to be the most superior circuit. Well, there's an answer for that. And that is volts versus amperage. Now volts is basically the difference of potential that would drive 1 amp of current, meaning that 12 volts here, let's say, that's the potential of moving all 12 volts through this guy. And it's important to note that when we look at these of volts versus amps, we have to look at them in the context of what our circuit is. Is it series or parallel? So volts in a series circuit is pretty easy, right? So we have 12 volts, our battery here. This is the symbol for battery. And it's going to be flowing this way. And we get to, say, our first light bulb here. Well, in a series circuit, anytime you have a, let's just call it a device in there, a light bulb in there, it's going to draw a certain amount of power away from it. So in this case, it's a 4-volt light bulb. So then it's going to take 4 volts away. Okay, so then that leaves me with how many volts? 8 volts left. So then I would have 4 volts for this light bulb, 4 volts here, and then I'm able to use all of the potential energy of 12 volts here. Now, say I have a number that's too large, like I have a 8-volt light bulb here, 4-volt here, and a 4-volt here. Well, that's too much for what my battery can power. Now, what might happen is that this will shine brightly because it's taking all the energy. This is going to shine about how it would, and this might get a little trickle of energy, so it's going to shine a little dimmer. We can do this on our Arduino set to test it out. So we can have our Arduino light, and we can use our breadboard, and I'll show you this in a second, and connect a bunch of lights in series. And you can see how the power starts diminishing the further we go. It's really cool. Now in parallel, this is where it gets kind of convenient. So maybe I have a whole bunch of 12-volt motors that I need to run. So I could have a 12-volt motor here, 12-volt here, and 12-volt here. And it's all fine because all of that potential is still going where it needs to go. It can all flow correctly. Now in terms of amps, well, an amp is just a unit of electrical current. So higher amps really means you can power larger items, whereas higher volts means you can power more items. So in our series circuit, say we're starting with, let's say 0.3 amps. Well, in the series circuit itself, everything will receive that exact same amperage of 0.3 amps. It's all going how it should. So in this case, it's going around this way, right? So we're at 0.3, 0.3, 0.3. And then back here we can measure again 0.3. Before it we can measure 0.3. It doesn't change in series, which is useful if you have something that's requiring a specific amperage to use. You can put that in series. Whereas in parallel here, if we're starting with 0.3 amps and we're going here, well, you can see that my 0.3 amps is going to measure as 0.1 here, 0.1 here, and 0.1 here. And then back, because it all has to equal out in the end, 0.3 here. So at the start I'm at 0.3, but then as it goes along, I'm losing amperage down the line. And then I put my 0.3 here. Now there are special things we can do with batteries specifically, like we can add batteries in series or parallel, and we can increase our voltage, we can increase our amperage in different ways like that. So understanding how to do that, and we'll get that as we move later on in this course, it's going to help us create better and cooler circuits and designs. Now, we're not going to talk about ohms and resistance just yet. We're going to save that for our next lesson when we work on creating a button. If you have any questions, please feel free to leave them on this video here, or if you're watching Google Classroom, drop it in Google Classroom or ask me in class. Hey, thanks for watching.